Okay, welcome back everybody to more about parallel lines and transversals. In today's lesson, we have three new theorems and one new postulate. And so let's go ahead and get started. The topic is angles formed by parallel lines and transversals. So we'll be looking at specifically the angles formed by when two parallel lines are cut by transversal, and they have names, and they can be congruent or supplementary depending on the theorem. So let's take a look at what we got first here. So the first topic we want to talk about is the corresponding angles postulate. So this one does not require proof. Remember, a postulate is simply a statement that we accept without proof. And it is this: if two parallel lines are cut by a transversal, then corresponding angles are congruent. So we already know what corresponding angles are. Those are angles that are on the same side of the transversal, either both above or below their parallel lines. So this postulate says that when you have two parallel lines that are cut by a transversal, corresponding angles are congruent. So if we look at angles 1 and 5, they're corresponding. So now we know by the postulate that they are congruent. Angles 3 and 7 are also congruent by the postulate. Angles 2 and 6 are corresponding. So now we know they are congruent. And angles 4 and 8 are congruent because they are corresponding angles formed by these parallel lines in the transversal. So that's what we need to know. And then that postulate is going to be used then in later theorems. So I got a couple examples for that. So here's example number 1. It says find the measure of angle ABC. So you see we have two parallel lines. Remember, these little arrowheads here indicate that those lines are parallel. So we have two parallel lines cut by a transversal. And so we know that the 80-degree angle and the x degrees are corresponding angles, and so they're going to be congruent. So the measure of angle ABC, which is really that x there, is going to be just 80 degrees. Easy enough, nothing to calculate there. Just look at it, look at the drawing and look at the postulate. Okay, let's look at one more example before we get into the three proofs. This one says in example number 2 here, find the measure of angle DEF. So we can see angle DEF there. Let me highlight it right here, angle DEF. So we can find that, of course, if we know x. And so what we'll do, our plan is to figure out x, and then we'll plug x in, our number for x there, and then add 30 to it, and we'll have angle DEF. So we know from the postulate that those two angles, the 2x minus 45 and the x plus 30, are going to be congruent because they're corresponding angles here. So we're just going to say 2x minus 45 is equal to x plus 30. Subtract x from each side, so we got x minus 45 is equal to 30. So now we have x equals 75, but remember, we're not done there because we want angle DEF. So the measure of angle DEF, then we got to go one more step and take that 75 plus 30 and get that 105 degrees. So that's the measure of angle DEF, 105 degrees. Okay, now what I'll do next is we'll prove three theorems with two column proofs. And then after that, we'll follow that up with a couple examples, and then that'll be it for this notes here. So let's look at our first theorem of the day, first out of three. It's called the alternate interior angles theorem. Remember that alternate interior angles are on opposite sides of the transversal, in between the parallel lines. So the theorem says if two parallel lines are cut by a transversal, then alternate interior angles are congruent. So we're going to do that two-column proof. So you see line L and M are parallel. You can see that by the red arrows. And then we have some numbered angles there that we're going to use in this proof. So according to the theorem, remember what follows if is the hypothesis. So that's the given. So line L is parallel to line M. That's the hypothesis. And we're going to prove the conclusion. We're going to prove alternate interior angles are congruent. So in this drawing, we're going to prove that angle 2 is congruent to angle 3. So as we know from our proofs already, we're just going to write down that given as our first statement. So line L is parallel to line M by reason of given. Angle 1 is congruent to angle 2. So if you look at their orientation here, those are vertical angles. And we had a theorem earlier in the year, vertical angles are congruent, which we already proved. So now we're using that theorem to prove a new theorem. So vertical angles are congruent is our reason for statement number 2. Angle 1 is congruent to angle 3 is statement number 3. So if you look at the diagram, those are corresponding angles. We just had the corresponding angles postulate, which is restated here. If two parallel lines are cut by a transversal, then corresponding angles are congruent. So that's our reason for statement number 3. Now, look at these two statements put together. All right, so we got angle 2 congruent to angle 1. Angle 1 is in turn congruent to angle 3. So by the transitive property, we can say that angle 2 is congruent to angle 3, which is what we're trying to prove. So there you have it. That's the alternate interior angles theorem. Okay. Now we have the alternate exterior angles theorem. So this one reads almost identically to the one we just had. If two parallel lines are cut by a transversal, then alternate exterior angles are congruent. So you see my diagram, line L is parallel to line M. That's given. That's part of your hypothesis. And you're trying to prove the conclusion that those alternate exterior angles there, 1 and 2, are congruent. Okay, well, let's take a look at the proof of that. Shouldn't be too long. Statement number 1, as usual, is what's given. So line L is parallel to line M. That's given. Statement number 2, angle 1 is congruent to angle 3. You can see that's because they are vertical angles, and we got a theorem for that. Vertical angles are congruent. Statement number 3 is angle 2 is congruent to angle 3. That's the same postulate that we used earlier. That is, if two parallel lines are cut by transversal, then corresponding angles are congruent. So we've used that postulate now in our second proof. And then our fourth statement, we're going to conclude what we're trying to prove. Angle 1 is congruent to angle 2. And again, look at these two statements taken together and see that angle 1 is congruent to angle 3 and angle 3 is congruent to angle 2. So angle 1 must be congruent to angle 2 by the transitive property. So that proof is very similar to the one we just did with alternate interior angles. Okay, we got one more proof to go through today. This one is the same side interior angles theorem. So remember, same side interior angles are on the same side of the transversal and in between the parallel lines. So here's what the theorem says. If two parallel lines are cut by a transversal, then same side interior angles are supplementary. Okay. So we're given the diagram. So line R and line S are parallel. You can see it's indicated by the arrows there. And so that's given as part of the hypothesis. We are trying to prove that the same side interior angles are supplementary. So we're trying to prove these angles 1 and 2 here are same side interior angles. We're trying to prove that they are supplementary. So I wrote that down. That's where we're heading. Okay, let's do our proof. As usual, the first statement is what's given. So line R is parallel to line S. That's given. Statement number 2, angle 1 is congruent to angle 3. We've been there before. Those are corresponding angles. And we got a postulate for that. If two parallel lines are cut by a transversal, then corresponding angles are congruent. So we have that. Angles 1 and 3 are congruent. Statement number 3, angle 2 and angle 3 are supplementary. If you look at that, these two angles form a linear pair. Angles 2 and 3 form a linear pair. And so in our statement, angles 2 and 3 are supplementary. We can get that by the first theorem we had this year. If two angles form a linear pair, then they are supplementary. So we use that very first theorem of the year that we had in this proof to say that angles 2 and 3 are supplementary. Okay, look at statement 4. So it says the measure of angle 1 is equal to the measure of angle 3. That follows directly from statement number 2. We said those two angles are congruent. Now we're saying their measures are equal by the definition of congruent angles. Definition of congruent angles. All right, look at statement number 5. Statement number 5 says the measure of angle 2 plus the measure of angle 3 is 180 degrees. That follows directly from statement number 3, which said those same two angles were supplementary. So by definition of supplementary angles, we can say that the measure of angle 2 plus the measure of angle 3 is 180 degrees. Okay, now look at statements 4 and 5. Take these together. All right, so in statement 6, we say the measure of angle 2 plus a measure of angle 1 is 180. It's the same thing as the equation directly above it, except angle 3 got replaced by angle 1, so that's substitution. So now in statement 6, we have the measure of angle 2 plus a measure of angle 1 is equal to 180 degrees. So how do we go from statement 6 to statement 7? Well, those two angles add up to 180, so we say they're supplementary by the definition of supplementary angles. So you're starting to get the feel for proofs. Notice in this proof we used previous definitions, we used substitution property, and we used a postulate and a different theorem. So we've used a whole bunch of stuff as our reasons in this proof, which is what we're going to do all year long whenever we do a proof. Okay. Okay, well, that's three theorems and a postulate, so let's maybe work some problems here. I got a couple more for us before we wind this down. So if you look at example 3 there, you see two parallel lines cut by transversal, and the directions say find the measure of angle EDF. So let me highlight that so we're all looking at the same thing, EDF. It's this one. So what you notice there is that that angle and the 125-degree angle are alternate exterior angles. And so we just proved a theorem a few minutes ago, which said if two parallel lines are cut by transversal, then alternate interior angles are congruent. And so there's nothing to calculate here or figure out. X is, or that angle is 125 degrees. Okay, nothing to calculate there. Just know the theorem that goes with that picture. Okay. Looks like we have one more problem today then. So notice in example 4, you have two parallel lines, R and T. You can see that by the arrows, the red arrows. If two parallel lines are cut by transversal, then same side interior angles are going to be supplementary. So those two angles that you see marked there, 13x and 23x, those are same side of the transversal in between the two parallel lines. So they're same side interior. Pull out the theorem. If two parallel lines are cut by transversal, then same side interior angles are supplementary. So that means we need to write an equation saying that those two angles add up to 180. So we got 13x plus 23x equals 180. Okay, so our strategy, of course, is we're going to solve for x. Then we're going to take that x and plug it back in and multiply by 23 to get angle TUS. I should have highlighted that angle. We're looking for this angle right here. So as soon as we find that x, we can just plug it in there and find our angle. So if we add these two like terms together, it's going to give us 36x equals 180. 36x equals 180. So divide 180 by 36, and you'll get 5. It comes out even. Okay, so now we can go ahead and address the issue that we were asked to solve here. So find the measure of angle TUS. It's going to be 23 times that 5. It's going to be 115. And don't forget that's an angle, so that's got to have a degree symbol in there indicating degrees for that angle. Okay, so to kind of summarize here, we've had one new postulate and 3 new theorems. The postulate is, and by the way, notice that all 4 of these start the same way. If two parallel lines are cut by a transversal, here's what we know. If two parallel lines are cut by a transversal, then corresponding angles are congruent. That was our postulate. And then we had if two parallel lines are cut by a transversal, then alternate interior angles are congruent. That was a theorem. Then we had if two parallel lines are cut by a transversal, then alternate exterior angles are congruent. That was another theorem that we proved. And then finally, we had if two parallel lines are cut by a transversal, then same side interior angles are supplementary. Okay, so what you got to be able to do when we work these problems and then going forward is recognize when you have those types of angles and whether they're congruent or supplementary. Okay, so the assignment is posted, and so see if you can give that a try and make some sense out of it, and we'll talk about it in class. Bye.